Energy. It's a word that we've all heard of, and all of us have a basic understanding of what it is. Some may immediately think of exercise, while for others, transportation comes to mind. Those of you who have taken a basic physics, chemistry, or engineering class most likely know of kinetic energy. This is the energy of motion. All moving objects have kinetic energy. The more massive an object is, or the faster it moves, the more kinetic energy it will have. You've probably also heard of potential energy. This is stored energy that is associated with an object's position. So for example, a ball being held up in the air has potential energy. But today I'd like to discuss different sources of energy that society has and potentially will rely on in the future. I'd like to begin with petroleum and its derivatives. So first, what is petroleum? Petroleum is this naturally occurring liquid found beneath the Earth's surface that can be used to fuel vehicles and heating units, and also to create plastics and petrochemicals. Petroleum is primarily composed of hydrogen and carbon. Petroleum is a fossil fuel, meaning that it exists because of the decomposition of organic material over a long period of time. Petroleum is found in what we call reservoirs. The most common method of extracting oil is by drilling a well. From here, the petroleum is transported to a refinery to be processed into gasoline, diesel, jet fuel, and much more. The main benefit of petroleum is that it's easy to store and easy to transport. There are 4 primary methods of transporting oil: pipeline, rail, truck, and ship. The most common is through pipeline. The term oil sands, it's also known as tar sands, is used to describe a mixture of sand, clay, and water that holds an extremely heavy crude oil known as bitumen. Bitumen is incredibly viscous. This just means it's thick and it does not flow very easily. Because it is so much more viscous, it cannot be drilled the normal way. Other methods had to be developed, and currently the most common 2 methods are open pit mining and in-situ, or underground methods. Open pit mining is when tar sands are scooped up out of the ground and sent into large trucks, which then deliver them to a facility that crushes the tar sands and heats it up to separate the bitumen from the sand. But usually the oil sands are found far underground, so a different class of techniques, in-situ, must be used. The most popular in-situ method is called steam-assisted gravity drainage. Basically, steam is pumped underground through horizontal wells, and the tar sands liquefy. They're then pumped to the surface. The 2 biggest tar sand reserves in the world are located in Alberta, Canada, and Venezuela. Because it is much harder to extract, this oil is far more expensive, and the extraction process produces much more carbon emissions. Additionally, the water that is used to separate the bitumen from the sand cannot be recycled back into the ecosystem, although I should mention that companies are working on a solution to return the wastewaters to their natural state. Another problem is oil spills. A large oil spill usually refers to an oil spill in which over 700 tons of oil were spilled. A medium oil spill is one in which 7 to 700 tons were spilled. In 2017, there were 2 large oil spills and 4 medium oil spills. The total amount of oil spilled in this year is estimated to be around 7,000 tons, most of which occurred in a large oil spill in the Indian Ocean. Oil spills have catastrophic effects on the environment, although I should note that over the past few decades, the occurrence of oil spills has drastically declined. Another problem that comes with oil is that it can have negative geopolitical effects. Countries in the Middle East can and have historically manipulated oil prices to sway the political climate of Western democracies. On top of all of that, burning it releases carbon into the atmosphere, and this contributes to climate change. And this is something I'll touch on more later. Now let's take a look at natural gas. Natural gas refers primarily to methane, and small quantities of a few other hydrocarbons. Natural gas is also a fossil fuel. Natural gas is also found in reservoirs, surrounded by an impermeable rock known as cap rock. There are 2 types of natural gas, wet gas and dry gas. Dry gas is just methane, whereas wet gas contains methane along with ethane and butane. These natural gas liquids can be separated and sold if needed. Conventional natural gas reservoirs can be drilled with wells. However, there are 3 other forms, each with its own extraction method: shale gas, coal bed methane, and tight gas, also known as sour gas. Once extracted, natural gas is sent through pipelines called gathering lines to be processed. Sometimes the natural gas is condensed into liquid and shipped on a tanker. Natural gas can be used for heating, to generate electricity, and much more. One of the major benefits of natural gas is that it produces lower carbon emissions compared to coal and oil. On top of that, for the US and a few other countries, it has improved energy independence and brought down energy prices. It also has some disadvantages. When extracting the natural gas, there can be leaks. Methane is a colorless, odorless, toxic gas, so it could harm nearby populations. Additionally, a leak could mean methane enters the atmosphere, and methane is a far worse greenhouse gas than carbon. Another problem is with hydraulic fracturing, commonly known as fracking. It's a technique used to extract oil and natural gas from tight locations. Basically, a vertical well is drilled to the desired depth, then the well is drilled horizontally for several thousand feet. Then a mixture of water, sand, and other chemicals is used to break up the reservoir, and shale gas rises up and is collected. The mixture of water, sand, and chemicals is sucked back up. Approximately 11 million liters is used per well. Additionally, some of the chemicals that are used in the mixture are toxic, and not all of the mixture is sucked back up. This contaminates the surrounding area. There is also speculation and controversy around whether or not fracking causes enhanced seismic activity, or earthquakes. Now let's move on to coal. Coal is a black combustible rock made of carbon. Coal is also a fossil fuel. There are four main classes that coal is grouped into based on the amount of carbon it contains: lignite, subbituminous, bituminous, and anthracite. Usually, the higher the grade of coal, the cleaner it burns and the more uses it has. It can be extracted through underground mining or surface mining. Coal is most often burned for heating and producing electricity. When converted to electricity, coal is first milled to a fine powder. This is done so that it burns quicker. The hot gases and heat produced from this process is used to convert water into steam. That steam pushes a turbine, which powers a generator. Coal has been the fuel of industrialization for many nations throughout history, and this trend continues today. It provides around 40% of the world's electricity. But coal also comes with certain baggage. The mining practices may have harmful effects to the coal miners and the environment. Another problem is that compared to other fossil fuels, coal produces the most carbon dioxide when burned, mainly because it is composed primarily of carbon. Sulfur, nitrogen, mercury, and heavy metals are also released into the air when coal is burned. As a result of all these harmful emissions, people are really looking into clean coal technologies. One example of this is carbon capture and storage. The three sources of energy I've discussed so far, oil, natural gas, and coal, all produce carbon when burned. This has led to a discussion around climate change. Okay, so what is climate change? First, you need to understand that there is a natural carbon cycle. This involves plants, animals, volcanoes, and more. You should also know that carbon is a greenhouse gas. The problem with fossil fuels is that we're taking carbon that is not part of the natural carbon cycle and adding it in. This has led to a higher concentration of carbon in the atmosphere. So what's actually the problem? Well, if more carbon is in the atmosphere, then that could lead to higher average global temperatures. That could also lead to rising sea levels. The sea levels would rise because ice that is above sea level melts. In particular, there are two major ice sheets that we need to be worried about: Greenland and the Arctic ice sheet. Another problem is ocean acidification. So just to recap, when fossil fuels are burned, CO2 is emitted into the atmosphere. A large amount of that CO2 has been absorbed by the ocean, which is why it's often referred to as a giant carbon sink. This is pretty good since it means less CO2 is in the atmosphere, but as the ocean warms, it will absorb less CO2. Additionally, if the ocean contains far more CO2, then certain marine life will be damaged. Carbon dioxide mixed with water leads to the creation of carbonic acid, and this increases the pH of the ocean. Because the ocean has become more acidic, coral and the shells of oysters and clams and other shellfish have become weakened. But not only are the clams and coral affected, but the fish that eat coral and clams will also decline. Many people in the world rely on seafood, and this could also cause a large food shortage. I should also note that 1 in 4 ocean species lives in coral reef ecosystems, so this isn't by any means a small problem. So let's take a look at some alternatives to fossil fuels. I'll begin with a renewable source of energy: solar energy. Simply put, the sun's heat or light is converted to another energy source for use. There are primarily two types of technologies that do this: solar photovoltaics and solar thermal. Solar photovoltaics, commonly referred to as solar PV, is a technology that converts sunlight directly into direct current electricity. Solar thermal, on the other hand, uses the sun's heat energy for electricity production and heating. There are many benefits to solar energy. First is that solar energy is renewable. We won't run out. The next is that it does not emit any greenhouse gases. On top of that, solar PV removes the need to have large centralized production sites. People can have solar panels placed right on their own roof. This allows you to not only be a consumer, but also a producer. One of the things that's really helped solar energy is large-scale implementation and advancements in the technology, and this has led to a rapid decline in costs. There are also a few roadblocks with solar energy. Intermittency is also an issue. So here's what I mean by that. On one day, the sun might be shining a lot, and later in the week, it might be shining very, very little. Let's now go over wind power. The idea here is to turn the wind into mechanical energy. We started out with windmills hundreds of years ago, but now we often use wind turbines. The blades on a wind turbine are connected to an electromagnetic generator, and when the blades spin, electricity is generated. Wind power has been gaining popularity over the past decade. One of the major benefits is that electricity generated by the wind does not produce carbon dioxide emissions. One of the major problems with wind energy is that the wind does not blow all the time. This can cause intermittency issues. Another problem is that it can lead to land, noise, and bird disruption. These type of problems are often referred to as NIMBY concerns, which is short for not in my backyard. Now let's talk about nuclear energy. We can obtain this energy by using two types of reactions, fission or fusion. Fission is when a heavy, unstable atom breaks apart into two smaller atoms. Fusion is a very similar process. Two small atoms are slammed together. The sun uses nuclear fusion. The energy released from these reactions is in the form of heat, and the heat can be used to turn water into steam, and the steam can push a turbine that is connected to an electromagnetic generator. Nuclear fusion is a reaction that is very difficult for us to create, which is why all of today's nuclear power plants use nuclear fission. The fuel most commonly used for fission is uranium. Around 11% of the world's electricity comes from nuclear fission. So one of the major benefits of nuclear energy is that nuclear power plants have low operating costs. Another benefit is that nuclear energy produces no greenhouse gas emissions. One of the major obstacles for nuclear energy is the massive initial costs required. Another concern has to do with radioactive waste. Some of these materials can remain radioactive for thousands of years. Another obstacle for nuclear energy is public perception. Now let's move on to energy derived from water. Hydropower, often referred to as hydroelectricity, is when moving water moves the blades of a turbine, which is connected to a generator, which produces electricity. There are really two situations in which hydroelectricity may be used: dams and run-of-river. These dams, often referred to as hydro dams, are created to create reservoirs of water at a higher level and also to control the flow of water. Sometimes when energy is in high supply, the water in the lower reservoir is pumped back up. Think about it. If energy is in high supply, then that means you may not need the excess energy at the moment. So why not use that excess energy to pump water back up? Later, when the energy is needed, it will flow back down. The second type of hydroelectricity is run-of-river. The main difference is that a naturally occurring river is used instead of a dam. Since run-of-river depends on natural water variability, it has more intermittency issues than hydro dams. Hydroelectricity is the most common form of renewable energy when it comes to electricity production. One major benefit is that neither hydropower nor tidal power directly produces greenhouse gas emissions or air pollutants. Another benefit is that it is a cost-competitive form of electricity. This means that costs compared to its competitors can be very low. Additionally, this renewable energy is far more reliable than other sources of renewable energy. It doesn't suffer from the same intermittency issues. It also has its drawbacks. One potential problem is that the construction of dams can occasionally cause damage to the surrounding ecological system. On top of that, people living nearby may be forced to relocate, and perhaps the most dangerous potential negative side effect is a dam failure, although I should note that this rarely happens. The last source of energy that I want to discuss is biofuel. Biofuels are combustible fuels that are derived from biomass. The term biofuel most commonly refers to ethanol and biodiesel. Ethanol can be used as an additive or substitute for gasoline. Biodiesel is an oil that is extracted from plants and seeds. It can be used as an additive or substitute for diesel fuel. There are three classifications of biofuels. First-generation biofuels are formed from food crops. Ethanol is formed most often from corn and sugarcane. First-generation biodiesel comes from soybean oil and canola oil. Second-generation biofuels are formed from cellulosic material. This includes woods, grasses, and other inedible plants. Third-generation biofuels are formed from the lipid production in algae. Advanced biofuels refers to biofuel derived from waste, animal fat, and used cooking oil. One of the major benefits with biofuels is that it's the only energy source that can replace petroleum fuels with regards to the combustion engine. While it's true that electric cars may become popular, there are many cars that are currently in use or that have been recently bought that are still going to last for the next decade or two. And these cars do not have an electric engine, they have a combustion engine. Another benefit is that regions that do not have oil reserves, gas reserves, and large coal mines can become energy independent. They can just grow their fuel out of the ground rather than have their politics affected by Saudi Arabia, Iran, and other suspect countries. Concerns include deforestation, biodiversity loss, and water and fertilizer usage. I'd also like to discuss specific countries that may be of interest. Here is a breakdown of energy consumption in the US in 2017. Petroleum comes in first place, natural gas in second, and coal in third. Renewables come in fourth place with around 11%, with biomass and hydropower leading the way, and nuclear energy comes in last place with 9%. We can break down the recipients of energy into four classes: transportation, industrial, residential, and electric power. We can also see that fossil fuels lead the way in each one of these sectors. When it comes to energy production, fossil fuels once again lead the way. Around 77.6% of the US energy production is in the form of fossil fuels. In 1973, France underwent an oil crisis, and as a result, Prime Minister Pierre Mesmer announced the Mesmer Plan, in which France would heavily invest in nuclear energy. In the year 2016, France's electricity production was a total of 556 terawatt-hours. Around 72% was nuclear energy. 12% was hydropower, 8% was coal and gas, and around 5.6% was solar energy. France produces more than enough electricity for its populace, so it exports electricity to Italy, the UK, Spain, Germany, and others. Here's a list of some of the top oil-producing countries. Here's a list of countries emitting the most carbon, for the whole population and per capita. I should also discuss Germany, a country which ranks 6th in electricity consumption. Germany has heavily invested in wind and solar for the past few decades. I should note that negative pricing was an issue. Basically, imagine how a supply and demand curve can look when the demand is extremely low and the supply is incredibly high. The price becomes negative, meaning the government must pay people to use the energy. Germany's CO2 emissions had slightly rose in 2015. Once again, this was due to the fact that on some days energy was needed and the sun wasn't shining enough and the wind wasn't blowing enough, so alternative sources of energy like coal had to be used. Innovations in battery technology are the key to solving Germany's negative pricing issue, and the bigger problem of intermittency in wind and solar. So that sums it all up for this video. If you liked it, please consider donating to my PayPal or Patreon account so I can continue to make them. Thanks for watching, and I'll see you later.